All right. All right, so for the quiz, okay, this is the last quiz of this chapter. So we're going to do the quiz review on sections 3.4 and 3.5. And then we will start the test review. Now, tomorrow we've got art for the majority of this class. So you will, we'll probably finish this tomorrow, if not today, or just, so the quiz will be on Wednesday, because I don't think we'll have enough time between when class starts and when we have art. Okay, so on the review sheet that you've got, we have 1 through 4 is working with a set of particular points. And this is from section 3.4. And so it is asking us to use points 7, 2, and 9, 1. So the coordinates for those 2 points to calculate these 4 things. And my door's open, so it's loud. Getting cooler in here. 3.3, we can do that. All right, so for the first one, hold on, let me see. All right, so we've got 2 points, 7, 2, and 9, 1. All right, so for number 1, we're told to calculate the distance. What's the distance formula?
I have a note card somewhere.
We know it involves a square root, right? Right, so we have D equals, that's okay, Aiden's back there getting it. D equals what? It's the difference between our x coordinates plus the difference between our y point, both of them squared.
Square root of x.
Let's get the, yeah.
2 minus x1 squared. Plus y2 minus y1 squared.
Put that up there, sorry. Y2 minus y1 squared. All right. The important thing to remember is that the squared of those differences does not cancel out the square root of the whole problem. That would only work if they were being multiplied times each other. So let's define our points. This is a me thing. I've always had to do this. Otherwise, I'm going to get them all put in the wrong order, end up with a completely different number. So I'm going to go ahead and I've got x1, y1, x2, y2. You can do this either way. I like to list it like this. You can also just, put it above them. But I like making a list of my variables and then plugging them into my equation right next to it. So x1 is 7, y1 is 2. Does it matter whether I choose my first coordinate or my second coordinate as my 1 or my 2? No. As long as you don't pick 7 as x1 and 1 as y1, right? Just don't mix them up. This first one could be that could be x2 and y2. It doesn't matter. The important thing is that you are keeping your, I guess, your proportions the same. You're keeping your coordinates together. Okay, so this one is 9 and 1. So when I write my final distance equation, yeah, thank you. All right, so x2, 9, minus x1, 7 squared, plus y2, 1, minus y1, which is 2 squared.
I wrote that down.
How so?
I did x1 minus x2 plus y1 minus y2. Will it still work that way?
As long as they're the same. Like as long as x1 and y1 are the first, subtracting.
Yeah, so
The second?
I did distance equals the square root of x1 minus x2 squared plus y1 minus y2 squared.
As long as they're paired the same, right?
Okay.
It's 1 minus 2, 1 minus 2. You'll be the same. The important thing is because you're finding the difference, but the fact that you're squaring it means that if it's negative, it's still going to end up being a positive. As long as you understand that a negative times a negative is positive. It is a little odd, isn't it? It'll be okay. And I got my glasses on, which I don't know if it scares people, but it
It doesn't
definitely,
really scare me.
it definitely just
I'm not used to
disorients
it.
them. Yeah, me either, huh? It's not like reflecting the flames of hell in my eyes or anything.
Not yet.
I try to
Depends.
keep
Depends
those.
on how Chad behaves.
Okay, all right, so now we simplify. So PIMDAS tells us that the grouping symbols, the parentheses, we take care of first. So this is 9 minus 7, which is 2. And then 1 minus 2, which is -1 squared. And simplify again. It doesn't because it's not negative, but it's good to just go ahead and make a habit of keeping them in parentheses, because if it does have a negative and you don't have it in parentheses, you're gonna mess up. It 1. I? -1 squared? It's just -1 times -1. I is an imaginary, that's a symbol for an imaginary number. So that is an actual mathematical term, but what's 1 times 1? It's 1. And 1 and I are not the same thing. So 2 squared, as Caleb told us, is 4. And -1 times -1 is +1. Therefore, our answer is square root of 5. Can we simplify this any farther? No. That is a perfectly appropriate answer. 5 is a prime number, so we cannot break it down into its prime factorization and pull any whole numbers out. So it's just the square root of 5 is very different than 5.
So that's the answer.
So you absolutely must include the square root.
I didn't understand the stuff that we did on Thursday.
The slope intercept, and
Yeah,
y-intercept
the
stuff,
that we did with Miss Rice.
and then you weren't here on
I wasn't
Friday.
here on Friday.
Darn, I should have recorded that class.
Yeah,
I think we'll work on it a little bit today, but I think you'll be
I
okay.
really didn't get it.
Let's get through this and then we'll see. So what's the midpoint formula? Oh,
B times X2 and Y2 is. I know it's the right one, but.
Okay, so I think it's in parentheses here, x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2.
Yeah, I don't know where I got it.
no chance. Yes.
Oh, I see where I got it.
So yeah, make sure that's right. So-
So it said A and B in the book. And that's what-
Well, you just have to remember for point A and point B, the midpoint is the average of their X and Y coordinates. It's the mean. Now, we have our point, we have this, so you would say that this is point A and this one is point B. But, so these stay the same. So X1 is 7. So what is this? 7 plus 9 divided by 2. And 2 plus 1 divided by 2. So 7 plus 9 is 16 divided by 2, and 3 divided by 2. So we simplify that to the midpoint falls at 8 and 1/2. 1 and 1/2.
This just feels like algebra.
It is just algebra.
Isn't it 8?
You could do 1.5, you could leave it 3.2. If you don't like mixed numbers, yeah, you can do 1.5, or you can just leave it as 3/2. Either one. Everybody good with distance and midpoint so far? Yeah, this is 3.4. It seems a little easy now that we've pulled
Now that
with
we've done slope intercept.
slope intercept. Love slope intercept. Huh?
How'd you get one?
Because 2 goes into 3 one whole time, and there's 1 left over, which is 1/2. 1 and 1/2.
Oh.
It's 3/4. 3/2 was 1 and 1/2.
I see what I did. Never mind.
Mhm.
I wrote 9 instead of 2.
Yes, that is why I go to the effort of labeling my X1, Y1, X2, Y2, because it is so easy when you have 1, 2, 3, 4, 5 different variables to get them plugged into the wrong place. You gotta be careful. Okay, slope formula. Right, so it's M equals the, easy there. All right, back there? You can go get some water. This is gonna be a fun video for Gabe to watch, that's for sure. All right, so what is rise? right, up and down, right? So it's the difference in your, so it's y2 minus y1, and the run is, I think crosscut run, yeah, flat surface, x2 minus x1. All right, so now we plug in, what's my y2? I'm like gone up ahead. Who has it? So y2 is
Actually,
2.
Y2 is 1.
Y2 is 7.
Y2 is 1. I don't know what Chad's talking about.
Y2 is
Y2
1. Y2 is 1.
Wow. All right, I'll just go check. So y2 is 1 minus y1, which is 2. x2 is 9 minus 7. All
It's
right,
negative 1.
right. So we have -1 and 9 minus 7 is 2. So that's just a -1/2. That's our slope. What does that mean? Our slope is going uphill, downhill. Huh? I heard a downhill, right?
Did you?
Yeah, because it's negative. Negative slope means it is as it moves across your x with the numbers increasing, your y is decreasing downhill. All right, so number 4 is your linear equation. What is the linear equation? That's the same thing as your y-intercept or your slope intercept. So y equals m times x plus b. So now this means for every y and x on the line, so those stay variables. What is my m? Slope, therefore it is -1/2. What's my b? How do I calculate my y-intercept? Poor thing. Nobody remembers? You remember?
Didn't say it, but
Wow, y'all are so sassy today.
Yeah, I don't want to say that.
All right. Well, what is one point that exists on this line?
what do you mean the line? There's no line.
Well, sure there is.
There is no line.
We need the linear equation for the line that would run through these 2 points. Any of these 2 points. Use the point.
7 and 2.
Okay, so 7 and 2. So we have y equals 1/2 x, -1/2 x plus b. So plug in 7 is my x, y is my,
Well, okay, then what I just said can't work. Okay,
so 2
7 is your
equals-
x, 2 is your y.
we got to calculate b. We've got to figure out where the line between these 2 points. So we have 2 points. We're finding a distance. What exists in a distance between 2 points? A line. Yes, a midpoint is there, but a line is there, a midpoint is there. There's a slope that tells us what direction this
2
line
is
is
your
going.
y. 2 is your y.
Okay, so 2 is my y and 7 is my x. I just pick one of the convenient points that this line goes through. Okay, and that helps us tell us where does this line intersect with the the y-axis. Okay, so b is our y-axis, so we can plug in an x and a y to calculate it. So 2 equals -7/2 plus b. So what do we do to isolate our variable b? We add 7/2 to both sides. Sure, that 2 becomes 4/2. Got to find a common denominator. Hopefully we all know what I just did. Okay. All right, what's 4 plus 7? It's 11. Lord have mercy. And 2 goes into 11 5 times with 1 left over. So 5 1/2 is where where this line intersects the y-axis. So we take our value for b, we go back to y equals mx plus b. Y and x, again, like I said earlier, those stay as our unknown variables because this line has infinite number of y's and x's. What's our slope again? -1/2 plus, you can write this multiple ways. You can write it as 11/2
5.5, I would say.
or 5.5. But if you do that, then you probably need to put -0.5 for the, because that's sort of having a fraction and a decimal kind of makes me twitchy. But either one is fine. We don't want to make the teacher twitchy, right? I'm, just so you know, I'm not looking up. You retaliate in any way. All right, so here's our linear equation. What are you saying? You're saying wrong?
Wait, bar.
Rar.
So E equals 5.5.
Or 11/2. Or 5 1/2, whichever, however you want to write it. We all know that's the same thing. Please tell me we all know that's the same thing. All right, there's our linear equation. Okie doke. So now let's move on to number 2. Find the coordinates of B if M, which is -1 and 1/2, is the midpoint of line AB. There should be a little line symbol over that, but I was in a hurry. And A is located at -3, 4. So what are we finding the coordinates for? Dun, 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 dun.
And B.
B, yep, what is B? So if I have line segment A and B, when in doubt, draw a diagram. I have a line segment AB. I have, I'm told that there is a midpoint. I'm gonna put it somewhere around right there. And that the coordinates of that is -1 and 1/2. And I know that A is at -3, 4. So this is obviously nowhere even remotely to scale. So I am finding my other endpoint. Okay. Yeah.
How do you say poles?
No, he says, what formula do I have to use?
Midpoint.
Mhm.
And midpoint, I would argue, is M equals x1 plus x2. You don't have to write the whole thing out. I saw what you were just about to. You don't have to do this.
That's okay.
Okay.
Okay, anyway, yes, so midpoint is -1, 1/2.
Wait. You're not putting the do.
I'm not doing the what?
You should divide by two.
Did I not?
You just gotta put it there.
Well, midpoint's not divided by 2.
Yes, it
That's its
is.
coordinate.
No, you're mistaken. Then why have you done this to me? Why? Okay.
But I
here.
know my midpoint.
What's that?
Yes.
As you've written above. M equals x1 plus x2 divided by 2. That's midpoint.
But
yeah.
we know our midpoint. We're calculating an endpoint. We're calculating x2, y2. Yeah, so
Get out of here.
x2, y2, that's our unknown. Okay, so everybody pay attention while I work through this, okay? Okay, so what you're gonna do is you're gonna split apart your midpoint formula, and first you're gonna calculate your x2, and then you're gonna calculate your y2. So what is the coordinate? What is the x coordinate of your midpoint? -1. So -1 equals x1 plus x2 over 2. And we already have an x1 and a y1. So plug in, so you have 2, oh, easy now, we're good? So we have 2 unknowns right now, but we can realize that we do have one of those variables. We have a value for it. So -1 equals, x1 is -3 plus x2 divided by 2. Now what do we do? Let's see, I need my 11th graders. Practice, let's practice your algebra.
Oh,
Yeah, James, Isaiah, we multiply what by 2? Everything, both, right, we multiply both sides. Pay attention. So these cancel each other out. So you're left with 2 times -1, which is -2, equals -3 plus x2. Last step. Isaiah, what do I do? What do I do? Yes, where? What do we add 3 to? Both sides. Why? Why does my phone never stop? Yep, I did. Okay. All right, so we finished that up and x2 equals 1. So now y, thank you very much, sir. Okay, so 1/2. Would you chill out? Yes, I'm talking to you. I can see you twitching from here. And I got my glasses on. Uh-huh. All right, so 1/2 equals, you have a y1, it's 4 plus y2 over 2. We divide both sides by 2. Use a different color. We're doing y now. Yeah, same process. You just figured out your x. Now you got to figure out your y.
I think I got it, but I don't.
There's not enough room.
No.
Well, use the other side of the paper then.
There's stuff
That,
on the other side.
there is definitely enough.
There's not, look.
All right. Divide both sides by 2. And you'll notice when you do that, that actually cancels your fraction on the other side as well. This is why it actually does help to do fraction. Have I lost you? I'm sorry. Wow. All right, so we just solved our x coordinate for our endpoint B. Now we're doing y. The 2 brings it to 1 equals 4 plus y2. All right, so Chad, what do I do? What's my last step to solve for y2?
That'd be subtract 4. I don't want to go back. We do subtract 4 from that side, subtract 4 from that side. -3 equals is your y2.
There we go.
I ran out of ruts.
Yeah, you did. So
I also did that wrong.
B
Wait, no, that.
is 1, -3.
I was going on the wrong side of the paper. That's probably my issue. Because I was on 4. Never mind.
I actually did it right. Shocker.
Her.
Y'all are going to come back
Wait, no, Miss Martin. How did this
with
happen?
silent lunch all next week. You're fine.
How do I have 1 equals 4x, y2?
No, it's just 4. I don't know. What do you have? It should be 4 plus y2. Do you need to clean up your plus sign? So it says 4 plus instead of 4x? Yeah, so let's turn that into a plus sign, and then you should be okay.
I'm so embarrassed. I'm so sorry. This one.
Okay. And so that leaves you with 1 equals 4 plus y2. And then you subtract 4 from both and you end up with your y coordinate of -3.
Oh, which the second one is just 1 equals 4 plus y over 2.
Not y over 2. Oh,
Yes.
okay. Okay. All right, good. Okay, let's move on to some slope intercept form. I was nice enough to go ahead and give you, this was actually copy and pasted from one of my whiteboards, so that's why that X and Y sort of, and the arrows look awful.
I've not done this even much.
Okay, yes, so stay with me here. All right, so slope intercept form is what? Then pay attention and quit growling in her face.
I didn't growl at her that time. Actually.
Okay, that was actually more of a zombie one, which is even creepier. All right.
Okay, that's fine.
All right, slope intercept form is what? Thank you. Y equals mx plus B. Same formula. So look at what we have for number 5. We have the equation 3x plus y equals 1. This we've done. This was the thing we did when we started, I think, section 3.4 and or maybe 3.5. You were here for this data.
I wasn't here on Wednesday.
All we have to do, look, we have to solve for y. So solve for y.
So would you say that y equals, no, it'd be y equals 3x plus 1.
Almost. What do you have to do to isolate the variable y? Let me ask that a different way. What is currently being done to y? Right. And so what is the opposite of addition? Yes. So you have to subtract 3x from both sides. So yes, so you end up with y equals 1 minus 3x, but does that match our slope-intercept form? The commutative property of addition tells us that 1 minus 3x is the same thing as negative 3x plus 1. Now, does that match our slope-intercept form? Y mx plus b. Right, and so what is m? No, what is the variable m stand for? Slope. What does the b stand for?
Linear equation.
The whole thing is the linear equation.
It stands for.
Y intercept. It is the y intercept.
That's what I meant.
I knew what you meant. You're good. Excuse me. Seriously. Seriously.
You're
Hold on.
talking in 2007 meme format.
Well, I'm struggling now. Where is that equation? Okay, I don't even remember. What were the colors that I used for it? I can't remember. It was like blue and red and green, but which one was which?
Just like cat thing this one.
No.
Cat.
Why? Okay, here we go. So Andrew, let me go ahead and give you this so that you have this as well. Y equals m times x
Oh my gosh.
plus b.
That's what you just wrote.
You never even solved the last one. What's going on?
Well, I'm not quite there yet. Hold on. I'm just making sure that he has this. So y, this is just the y coordinate. And a line has infinite y coordinates, right? Just whichever one, which matches, well, let me keep the color coordination going here. The x coordinate. This is old. Y'all have had this. Andrew missed this day. This is your slope. And then this is your y-intercept. So that is at what point on the y-axis does this line cross the y-axis?
Okay.
That's what y-intercept is. Okay, so in this case, they're wanting us, I lost my paper. Okay, they're wanting us to write it in slope-intercept form, which I just did. Here's your slope-intercept form. But then they also want us to graph it. So here's the question. Where on your graph does it cross the y axis? At 1, positive 1. And you know that because of your slope-intercept equation. So right here at positive 1, that's where it intersects. So what is the coordinate there?
1, 0. Yeah, 1, 0, 0, 1.
It is x is your 0, y is 1. Okay, so that gives you one coordinate. Why?
What's B?
The b is your y-intercept. So because of this equation, we know that it intersects the y-axis at 0.1 at 1 because of our y-intercept, right? That +1 in our equation, this guy right here. That tells us at what point our line intersects the y-axis. Yes?
Yeah. 1.
Yes, okay.
I'm sorry.
Now-
Get it.
So what does our slope tell us?
how much, which direction it goes in.
Your slope is.
That's part of it.
Your slope is.
So your slope is -3. Now, what kind of XY coordinate does that give us, Andrew?
-3.
Right, so if slope M equals -3,
Okay, so 3 to the left of y and x, so it's negative on both.
remember slope is rise over run,
Yes.
okay? So give me -3 in a fraction form.
-3 in a fraction form, -3 over 0. Or 1.
Yeah, so here's your rise. So take your, see, we intersect
Okay, so you go up, no, you go down 3
down 3 from what point?
from the vertex, or do you go from the y-intercept?
From the
You
y-intercept.
go down 3 from the y-intersect and to the right 1.
1, 2, 3, so about right here,
Yeah, and to the right 1.
and then right 1,
And
Okay.
that's okay.
and then that gives us another point.
Then you go up to the left.
Now, because I like to have 3 points, gives me a nice straight line. So what is another way to write -3 over 1?
1 over negative.
Well, 3 over -1,
3 over negative.
which means we go up
Up
3.
3
Mhm.
and over. Oh my gosh, I get
I don't
it.
get the how you go. There's one point I don't understand. That's how you go.
Okay, so our slope is -3. So give me -3, rise over run.
Oh.
Yes, that's why it's nice to keep it as a fraction, because your slope needs to be in fraction form. Right?
Oh, this is
Because
pretty
then you
easy.
see your rise over your
It's
run.
kind of easy now that I can say it.
Okay, so -3, we can write -3 as -3 over 1, right? But you can also write it as a +3 over a -1. That's still -3, right? So that's where that's how you figure out like your whole line. So in this case, having a slope of -3 is an extremely steep downhill. Like this one's, you're gonna bounce a few times going down this hill. This one's gonna hurt, right? And so there is your graph line. You good?
That's a negative.
It is a negative, and our slope is negative. -3?
Yeah, I didn't even, I wasn't paying attention to the number, I was just looking at the line.
Right. You what? All right, let's do it. Let's do it. You want to do this next one?
Wait, so what's the, what
Yeah,
is
let us
what
do
the
it on
right
our own.
first? The M equals -3 equals rise over run.
Slope intercept form is y equals -3x plus 1. Dude, slow your roll.
Who are you talking to?
You're not as funny as you think.
To me?
Yeah, you.
Roasted.
All right, 2x. It'll be fine. It will, right? It will. All right, Tad, give this to me in slope intercept form.
2x minus 3y equals 15.
Mhm.
You need to isolate your ay,
Mhm.
so subtract 2x.
Mhm. And that leaves us with what on the left?
3y equals 15 minus 2x. So actually, we can go to 3y equals negative 2x plus 15.
Almost. What'd you forget? Mhm.
I was trying to get.
I know,
you
but we
here.
need to keep moving. Like we've got more.
I wasn't.
Do you see it? That doesn't just disappear.
Negative 3y equals.
Yes. Don't let your subtraction disappear. It must become a negative sign. Carry it with the term that follows it. All right, so last step. Abigail, what do we do to isolate the variable x, y? y. What's currently being done to y? Right, and how do we undo multiplication? There you go. So we divide both sides by -3. All right, and so this becomes -2x over -3, which becomes 2/3 x plus, no. Oh, my goodness,
Back
you
it up.
had me for algebra.
I know,
You should know
Back it
this.
up.
-2x over -3 plus 15 over -3. What's a negative divided by a negative? All right, and then that x, it's just 2/3 times x. It's still x times 2 divided by 3. Don't act like you weren't just as confused. So that becomes a positive 2/3 times x. What is 15 divided by a -3? All right. Adding a negative number is the same thing as subtraction. So what is our slope-intercept form?
Y equals 2 over 3x minus 5.
There we go.
Can I help with the graph, please?
All right, yes, you may.
Minus plus 5?
I don't know, why would it not be +5? Where? Come on. Right, what's a positive divided by a negative? It's a negative. And what happens when you add a negative number? Same as subtraction. Subtraction by definition is the addition of a negative number. That's why the addition properties of equality work for subtraction. You're just adding a negative number. Okay, so yes, Andrew, where does this line intersect our y-axis?
Your slope is 2 over 3.
Correct.
Your y-intercept is -5. Please stop. man.
Okay.
This is my problem.
So 1, 2, 3, 4, 5. I'll make that green. All right, so there's 1 point. That's where we need to start, which means I might have to make this line a little bit longer. But anyway, we'll figure it out. Okay, so y-intercept is at -5. So how do you use your slope to find another convenient coordinate to create your line from? You do it. What is our slope? Easy now. Let me let Andrew's been gone, so let me make sure he's got this.
I've not got any of this.
So how do we say, what is slope?
Rise over run.
All right, so this means,
2/3 over 1.
that means we rise how many points?
You rise 2 points, and the run is
1.
3 points, yes? So you go up 2 and you go to the right 3.
There we go.
Crap, my line is exactly backwards. I did -2.
If you do, you have to do -2 and -3,
I did -2 positive 3.
which makes a negative slope.
So yeah, mine.
Yours is a positive slope. So what's another way we can write 2/3?
-2 over -3.
-2 over -3.
So you go down 2 from the y-intercept and you go to the left.
And you'll
to the
notice, yes, you go down 2 and then you go left 3. And you'll see they do typically mirror themselves. These points will always mirror themselves across the y-intercept. And so it creates a line.
Okay, I'm starting to get that.
And then you should have a line that looks something like this.
I do.
You good?
I think I get it.
Okay.
It's not as hard as it seems.
All right, let's look at the other side.
Go
Here.
other side.
Parallel and perpendicular lines. Write the slope-intercept form of the equation of a line that goes through 0.42 and is parallel to 3x minus y equals 1. Right? Right.
Yeah, whatever you say, teach.
All right. I'm going to go ahead and draw my, oh my goodness. Actually, you don't even have to do that. Okay, slope-intercept form of the equation. First. Okay. What do we know about the slopes of parallel lines?
They're equal.
They're equal, right? They're both going in the same direction at the same angle. So all we need to do in this first case, doing parallel, is we need to take our equation, 3x minus y equals 1, put it in slope-intercept form. So we subtract 3x from both sides, and this becomes negative y equals negative 3x plus 1. But we can't leave that negative, so that's dividing by negative 1. So you end up with a slope-intercept form of y equals
3x plus
minus, which is minus 1, right? All right, so what's your slope? 3. And we have the point. So this one goes through 4 and 2. So that means,
2 is the y. So 2
And
equals.
so 4 to the, no, you don't have to graph it. Let's do, you know, what, you're right. Let's do it without the graph. All right. Let me just double check myself here. Okay, so the thing that we have to figure out here is we have to figure out what our, so this is parallel to the line that has a y-intercept of -1, but this line does not have a y-intercept of -1. So we need to calculate b. So we m equals, no, sorry. Our equation y equals, that's our equation. Wait, no, that's our previous equation. I'm losing my mind. I'm trying to rush and I'm doing awful. Okay, so y equals m times x plus b. So we have the point, what point did they give us? 4, 2? So we need to calculate our b. We already know our slope because slope is the same. Right, 2 equals 3 times 4 plus b. B is our unknown. Negative 1 is the y-intercept of the line equation that they gave us. That is not the y-intercept of the one that goes through 0.42. These are parallel. Okay, let's move on. Okay, so 2 equals 12 plus b, subtract 12 from both sides, and your y-intercept is -10. So what's your equation? Go ahead, Andrew.
-10 equals.
Well,
This is incorrect.
it's this right here. What did we just calculate? We calculated b.
Oh, never. I'm so sorry. I don't think that 2.
So, well, this is for any point, any coordinate on the line. So it's y and x.
Y equals 3x. Minus 10.
Yep. There is our answer. Are you confused?
No, I just
I'll
want
look
to
at
go.
it again. I'll get for my face. I can slowly-
Okay, well, and there will be a video. Okay, let's do the next one.
What? We can do this tomorrow. We have that little bit of time before ours.
We do have.
I don't know. You gonna be here?
I'm gonna be here.
Or are you gonna try to
I'll
go
be
load the bus at 1:30?
here. Chad, no.
All right, we'll do the last two.
Trip out.
Y'all do the last two.
No, no, that's a bad idea.
Okay, yeah, if that one pulls you to use like these, if you're like, yeah, do these two, I'll be like, oh,
No,
okay.
do it. Do it and figure it out.
You're delusional.
No, you can do it.
No, you'll work.
It's just rise over run. All right.
I'm gonna run
Yeah.
away. I'm gonna